Hi, I'm Anindya Rai. I do research in computational material science. I'm going to walk you through some of the programming challenges that you're going to face in CPMSC course. To start with, we have activity 4 of exercise 1. For this activity, we need to first copy the program in the next page as a MATLAB script, and I have already done that and saved it as snow.m. So here it is. So to begin with, we try to see what this program does, and let's start with snow 5 as required in the exercise. And here what we have is something called Koch snowflakes. You can see like these look like this snowflake pattern, and to check out what this program does, if we input different numbers, let's start with snow 2, and what we see is that we have a much simpler version of what we just saw, where we saw there were much more small segments for each of these straight line segments that we see here. So let's try some more different numbers. What about if we have a negative number? We don't really have any division, it's just a plain straight line. Does it change if we give 0 as the input? Not really, it's still a straight line. What happens when we have 1? So we see there is just one division here coming up. With 2, we see each of those line segments that we saw, they're getting subdivided into more divisions. For 3, now we have an idea how this program is working. It's dividing each available line segment into 3, and then further into the small ones. What happens when we give a fractional value? So this looks like what we had for 3. So one thing to note for this program, there is probably no difference between having a fractional value. It's just rounded up to the next higher integer it feels, because snow 2 was different. It was simpler, and snow 3 was same as snow 2.5. So that was the first thing that we note. Then let's see what the exercise asks. Okay, so now in the spirit of deciphering a foreign language, let's go through this program and let's try to understand some general features that we can see without knowing details of programming. First thing to note that it starts with something as function, which is snow, which we also saved as the file name, but we can see that there is the same like function client and then function plotline. There are these 3 broad segments which we can say some descriptions of functions, and within this each of these functions we see that if we look carefully, that this client, then parentheses and some values, that is mentioned in the first function, and this other function plotline, that is also mentioned within the second function, which is cline. So function probably has a feature called function probably has some quote unquote function, and these can be mentioned or probably implemented or called through other functions. So that's something that we note. Then if we look carefully, we see that the way we are so-called calling a function, for example, the name of the function followed by parentheses and certain values, we see that there are other features which look very similar. For example, if we look at this function line, or rather this sentence, line followed by this parenthesis and some values, it looks very similar to how function cline is mentioned, but we don't describe it within the script. So that means MATLAB somehow knows that this is what the job of that specific function line is. So we can understand that there are some functions which MATLAB is already aware about, and there are some functions which we as users are defining. So line is an example of the second kind. It's a user-defined function. The other thing that we note is that, for example, in this function cline, we have something as if followed by some lines, and then there is else followed by something else. Similarly, in the first function, we have if followed by something and then else followed by something else. So these sound very much like normal human language, and these are logical statements where we have certain conditions perhaps, and these blocks of this program would execute if that logical condition is satisfied. The third thing that we note is that within the function cline, we have something called recursive calls, and followed by that we mention cline within the function cline. So you can imagine we are calling this function from inside it, and that's quite interesting if you come to think about it. For the fourth segment of this activity, we are trying to understand what this function cline does. We see that cline takes some arguments as x's and y's, and then there is this limit which shows up later in the under the logical statement if, and we see these other variables. They go in this mathematical expression to determine something which we are calling length, followed by square root and then something. Well, I mean sqrt, which most likely is square root. You might be familiar with that from other places. And this x5, y5, x1, y1, they look like they are the coordinates, and we are determining the length between these 2 points. And once we have the length, it feels like these other x's and y's, they are the points needed to subdivide that line segment between x1, y1 and x5, y5, because if you look at this, when we are starting with snow 0, we have just a line segment, but then when we are increasing the number, we are dividing this line segment into 3 parts, and then the middle segment, that is made into a triangular shape. So for doing that, we we need to know the coordinates of the points where we are breaking this original line segment. And with increasing number, increasing this original number that is going in the snow function, we are dividing each line segment into smaller and smaller segments. So for example, here, oops, we have divided each line segment more times. So going back to this function, here most likely we are finding the points where we are going to break the original line, and these recursive calls, we note that the first function call of this recursive calls, it's taking the one of the terminal points and one of the intermediate points. Then the next two are taking just the intermediate points that we have generated here right now, and the last one is taking the other original terminal points and one of the intermediate points. And we are performing this calling itself till we reach certain threshold, which is defined through the limit that we also included. So this way, for any higher number such as 5, we are generating this beautiful pattern, which is a fractal, because for each subdivision we are maintaining the original segment and aspect ratio, and this is known as Koch snowflakes, and it's pretty interesting to look at. For the last part of this program, for this exercise activity, unfortunately I don't have anyone with me right now who can make 2 changes while I'm not looking, but if we could do that, most likely it would introduce errors or some differences that we would have had to debug, and I'm hoping to show you that process in one of the later exercises, and we'll have to save it for that. So this is all about Koch snowflakes, and hope this was helpful. I'll see you later at one of the later exercises. Bye.